Hi, welcome to Smart Academy. Now we discuss the HCU MSc Physics 2018 paper solutions. So here we have a question on basic capacitors. So the question is, consider a parallel plate of capacitor with circular plates, each of radius r. So let me consider this is the parallel plate capacitor with circular plates that radius is smaller, let it be. So the separation between the plates is d here. This separation between the plates is small d. The capacitor is charged to potential V. So now we connected with a potential and a battery with V. Okay, and then they disconnected from the charging circuit. The separation of the plates is slowly changed from the D to D prime. So how much the work done value here? So nothing but we have to calculate the work done when the potential becomes zero as well as the distance separated between the circular plate distance will be varying. Then we have to find out the work done value. Initially the work done formula we have 1 by 2 CV square. Here C is the capacity of this circuits. Sorry, that's parallel plate capacitor. V is the applied potential. So then we have the other work done formula, V equal to 1 by 2 CV square of CV square. So here we have a condition here. Initially we apply the potential V and then this disconnected nothing but disconnected the circuit, nothing but the potential is 0 here. V value 0. Okay, and the distance varying between these two parallel circuits. Okay, the distance varying from D to D prime. Okay, so initially the capacity of this capacitor is, let it be C, and it varying from C to C prime. The capacitance change from the C to C prime. Okay, so the formula is, for we have the two capacitors of the capacitor and as well as the distances, that can be written as here 1 by 2 C1 minus C2 or C minus C prime of V minus V prime whole square. Okay, so this means here 1 by 2 C minus C prime. C means initially when we apply the V potential, the capacity value. So when V equal to 0, the potential disconnected here to the circuit, then that is C prime. The initial potential is here V and the final potential V prime value is 0 here. Okay, so here in this, for this formula we need the C and C prime values. So what is the C value? When we connected the potential to this circular plates V, that C equal to here, we have a formula that is epsilon naught A by D. This is the capacity formula, C equal to epsilon naught A by D. When it changes from the D to D prime distance here, it is D to D prime distance, that capacitance value, let it be C prime. C prime equal to epsilon naught A by this D prime. Okay, this initial value of potential is V equal to V. This final potential when we disconnected this V prime value 0. These values are substituted in the equations 1. We are getting the work done in this process. Okay, so that's W equal to here 1 by 2 C value, how much? This is epsilon naught A by d minus this epsilon naught a by d prime. This v value is okay, v equal to here v minus 0, that is v prime value 0 whole square. If you are simplifying this one, w equal to epsilon naught a by 2 of 1 by d minus 1 by d prime into v square. So this w equal to epsilon naught a by 2 of d prime minus d by this d prime into v square. Okay, so here we are asking question that the work done in this process is proportional to, so proportional to nothing but, now we are eliminating these constant values here from this equation. So that's w equal to epsilon naught a value. What is the a? A is the circular plate area, that is equal to here pi r square. Why? Because of this area, this plate constructed with the radius of small r. That's why we are taking here a equal to pi r square by 2 into d prime minus d by d prime into v square. So this epsilon naught and this 2 is constant, pi also constant. That's why this work done is proportional to this r square of d prime minus d into v square by d t prime. This is the resultant work done for this given problem. So this is tally with the equation. This A option is correct. Okay, thank you.